Hello folks, welcome back again to my channel. We were doing top interview 150 lead code questions. In the last video we completed the try data structure, implement try. Now we will do design, add and search words data structure. So let's just walk into it and study the problem statement. Design a data structure that supports adding new words and finding if a string matches any previously added string. So it's similar to the implement try question. Implement the word dictionary class. Initialize the object, add words, boolean, search words. Okay, this is the main problem statement of this question. Rest are similar to the try data structure. It says implement a function search returns true if there is any string in the data structure that matches word or false otherwise. Word may contain dots, where dots can be matched with any letter. Okay, so here is the catch. Earlier there is a method called prefix. Let's look into it. So there was a method called prefix where if a word starts with something, let's say the word is given apple and we given the prefix app, so that means this prefix contains and therefore we have to return true. Now it says that it can be a dot and dot can be any letter, or okay, so this is a wildcard character, so it can be matched with any letter. Now in this example, see, bad is a word and we were given that search for this word dot ad. So dot can be anything. So in this case we can assume that dot is b and ad remains, so therefore in this case we have to return true. So this is the only change from the previous try question. Now let's try to implement it. As you can see, like if you can think of it, we have to use a DFS for this. We also I think have the drawing for this. Yeah, so see, so in this case BAD, B, let's say A, and in this case D. So in this case BAD, the word remains. So if we encounter a dot, okay, let's say we encounter a dot. Where is the pencil? Okay, encounter a dot, let's say here, then we have to like traverse through this node, like okay, from A where it points, then again we have to check. In this case we will have dot here, then we have to traverse A, then D, and ultimately return that okay, this is true. Let's implement it. Most of the things will be similar to node. Let's similar to the try question, so I will copy from here the node class. There will be only one change in this class, will be we have to add a method to get all the letters, then it will return the array of letters. All right, word, whenever we have to like in the constructor we have to initialize the root, private node root. It's similar to the try method, try data structure, root equals to new node. All right, add word will be very similar to the try. Okay, let's just implement it. Let's not just copy paste. Node current will be root, and we have to traverse through each of the letter less than word dot length I plus plus, then character current I. If current dot contains ch, if it doesn't contains, then current dot add ch new node. I highly recommend to watch my previous video to get how this class is designed, how we traverse through the try data structure. So it's highly recommend, because then only you can understand how this node is designed and how we add a new character to it. All right, so we added it. Then current will be current dot get ch, and ultimately we have to mark current dot setend. Okay, is the spelling correct? Setend. Okay, now comes the search one. We have to use a helper function, because this is a DFS, this is a like this will be a recursion search. So therefore let's say search helper will pass the word. We will start from 0th index and we will pass the root node. All right, let's create this function. It will return boolean search helper. We will have the word, index and node. Let's name it current node. All right, now if index is equal to the word dot length, that means we have came to the end of the word, and we will return whether current node is the end of it or not. Is end. All right, because as you know that whenever we add a word, we mark the end of the word as we mark the end of the word in the variable isEnd, and we just have to return whether it is end or not, because maybe it's not the word, it can be a prefix, but we don't need prefix, we need a word. So therefore, yeah. Now let's extract the character ch equals to word dot current I. Okay, if ch is a dot, then what we will do? Okay, if it is a dot, then we will first fetch all the letters, like all the childrens of this node. All right, we have marked this at root. Now we will fetch all the letters. It will be an array. We name it childrens. We mark it current node dot get letters. Because of this, we needed this function get letters. Now we will traverse through the childrens. Let's name it child here, childrens. Now we will check, is child not empty? If it is empty, let's say we didn't added a word that starts with a, so it will be null. If it is null, then okay, we don't have to do anything. So if it is null, so if it is not null, then only we have to proceed further. All right, then if it is not null, then we have to do the recursion. Therefore and search helper, we'll pass it the word, we'll pass one, we'll add 1 to the index, and we'll pass the child. If this returns true, that means it is true. If nothing comes out of here, that means all the letters are empty, and this is dot, so that means we didn't find a word, we will return false. Okay, now we have checked the case where it will be a dot. If it is not a dot, let's say it is a pad, we'll check if current node, I mean if it contains the word p or not, like it contains the letter or not. Contains ch. If it doesn't contain, I mean if this is false, then return false obviously. Else if it is the, if it matches the word, let's say we had the word bad and it again says bad, in this case the first letter b, we have the letter b, it is neither a dot, it also contains the character, therefore we'll just proceed to the next node, node I plus 1, and then it will be current node dot get ch. Cool, hope you have understand. Now let's just try to run it. Yep, it ran. So I hope you have got the scenario, like how this works. So let's just submit it. Okay, it got accepted. Awesome. So thanks guys, to stay around. I will see you in the next video.